Okay, today we're going to talk about factoring special products. You guys learned a couple weeks ago when we were multiplying polynomials that whenever you have something like A, B, two numbers, or a binomial that you're squaring, hold please, let me get the right size ink again, that the formula for figuring this out is to square A, do 2 times the product of A and B, and then to square B. So for example, x plus 3 squared would equal to x squared plus 6x plus 9. And then you learned also if it was a minus b, you would square a and subtract 2 times the product of a and b and then square b. For example, x minus 5 squared is x minus 2 times 5 times x and then square 5. And then you also learned if you had something like a plus b and then a minus b, you just square a, square b, and stick a minus sign in between. Today, we're going to recognize them from this side and write them into what it looks like on this side, the product of 2 binomials. So here are these words, here are these again. All right, so we want to recognize what a trinomial is. And a trinomial is a perfect square if the first and last terms are perfect squares. So this 9x squared can be written as 3x times 3x, and 4 can be written as 2 times 2. And then if the middle term is 2 times the product of this and this, then it is a perfect square. So we're going to figure out if this trinomial is a perfect square. Let's see, that's going to be x times x, and that's going to be 6 times 6. And if I do 2 times x times 6, I get 12x. So this is a perfect square, and it would be x plus 6 squared. Now let's see if this is a perfect square. Well, 4x squared can be 2x times 2x. 9 can be 3 times 3. And so if this is 2 times 2x times 3, which is 12x, then yes, this is a perfect square. And because this has a minus sign right here, the answer to this is x minus 3 squared. All right, let's try this one. This is x squared plus 9x plus 16. I'm going to rewrite it so I have some more room. That's x times x. That's 4 times 4. And so this has to be 2 times x times 4. Well, I know that's 8x. This is, since 2 times x times 4 does not equal 9, we can't factor out that polynomial that way. That won't work. All right, so we're going to determine whether or not this trinomial is a perfect square. Let's see. This is x times x. That is 2 times 2. And that is 2 times 2x. So this factored out is x plus 2 squared. All right, let's try this one. This is x times x, and that is 7 times 7. And is this 2 times 7x? Yes, it is. And since that's a minus sign, the answer to this is x minus 7 squared. Let's try this one. 9x squared minus 6x plus 4. That's 3x, and that's 3x. So far, so good. That's 2 times 2. 2 times 3x times 2 is 12x. That does not equal 6x. So that is not a perfect square. Okay, Sometimes we will get into the difference of two squares, and so that was on our original notes. So if you have a perfect square here and a perfect square here and a minus sign in between, like this is x, x, and that's 3 and 3, it will be x plus whatever b is, and then x minus whatever b is. For example, this one. This is an x and an x. That's 9 and 9. So this is going to be x plus 9, x minus 9. Okay, so this one is 9p to the 4th, so that's 3p squared, 3p squared. That's 4q times 4q. So this would be 3p squared plus 4q and 3p squared minus 4q. Okay, so this is x to the 3rd times x to the 3rd. Wait a minute, that 7 isn't a square, so this is not a perfect square. All right, on this one, this would be a 1, 1, and that's 2. Oopsie. Whoa, I don't know what just happened. I think my bracelet, there we go. 2x times 2x, so this would be 1 minus 2x times 1 plus 2x. And then you can see that this would be p to the 4th plus 7q cubed times p to the 4th minus 7q cubed. All right, now let me look at this one. That's going to be 4x and 4x, but this y right here to the 5th is a curveball, so that is not the difference of two squares. It's not a perfect square. All right. So this is an example of when we would use this. A regular fountain in the center of a shopping mall has an area of 4x squared plus 12x plus 9. So I'm going to draw it. Here it is. 4x squared plus 12x plus 9. The dimensions of the fountain are in the form cx plus d, where c and d are whole numbers. Find an expression for the perimeter of the fountain, then find the perimeter when x is 2 feet. So what I need to do is look and factor this first. Well, if I factor it, I see that that's 2x, that's a 3, and let me see, 2 times 2x times 3. Oh, so this would be, the length of each side would be 2x plus 3. All right, because 2x plus 3 squared would be that, and length times width gives me the area of this. So now I just need to find the perimeter when x is 2 feet. So I substitute 2 in for x. For the length of each side, that's going to be 4 plus 3 is 7. There's 4 sides, so the perimeter is 28 feet. Okay, we'll just do a few more practice problems. This is an x and an x, and that's a 9 and a 9, and that's 2 times 9x. Yep, it works. So this is x minus 9 squared, because there's a minus sign right there. All right. This is 6x times 6x, 2 times 2. This is 2 times 2x, or 2 times 6x. So this would be 6x plus 2 squared. That is a perfect square trinomial. All right, let's try this one. This has a minus sign in the center. So this is going to be t3 plus 12, and then t cubed minus 12. Okay, you might want to work this on your own and then pause the video. And then when you get it worked out, I see this is going to be 4x to the 5th, and that's just going to be y. There's a minus sign right there, so it's 4x to the 5th plus y. This is the difference of two squares, 4x minus y to the 5th. Okay, this one looks like it's going to be, that's 4x, yep, that's going to be 9, 2 times 4x times 9 does equal that, so this would be 4x plus 9 squared. Okay, and then this one looks a little tricky, but that's x times x, 1 times 1. Okay, 2 times 1x is that, and that's a minus sign in between. So this would be x minus 1 squared. And then this is x cubed times x cubed. That's 8 times 8. 2 times 8x cubed does equal that. So this would be x cubed plus 8 squared. And then this one would be 3y plus 11 times 3y minus 11. Because that would be 3y times 3y. That would be 11 times 11. And there's no middle term, and there's a minus sign, which means it's the difference of two squares. Just like this one is. This would be 7 plus t cubed times 7 minus t cubed. There's no middle term, and there's a minus sign, so that's the difference in two squares. Okay. Oh, I see there's no middle term, and there's a minus sign, so if a and b are both perfect squares, and they are, that's d cubed, and that's 5. So this would be d cubed plus 5 times. Oh, I just realized that is a 9, not a 6. This is not a perfect square. I'm actually really glad I did that because I was going so fast I was thinking 3 times 3, but remember we add the exponents. So this is not a perfect square. Caught that at the last minute. And then our final example is, this is 4p squared. Yep, and that's going to be 10q's, and there's no middle term. So this would be the difference in two squares, 4p squared plus 10q, and 4p squared minus 10q. And that concludes our factoring special products, which was just the opposite of when we learned how to multiply special products.